Okay, good afternoon, good morning to everybody. This is Sebastian Revuelta speaking, and we have a new edition of the Kiuwan webinars. Today we will talk about how you can mitigate open source risk with Kiuwan Insights. Let me introduce myself. My name is Sebastian Revuelta. I'm Customer Success Manager at Kiuwan. It means that I am trying to help customers to speed up the use of the platform with trainings, webinars, tips, best practice, and so on. As career, I am software engineer. I am obsessed with data. I see data everywhere, graphs, metrics, statistics, plots. And of course, I love software quality and security. In my free time, I am chess player. To be honest, not very good. Let me introduce Eduardo Boronat, my colleague. He will introduce himself.
Thank you, Sebas. Hi, everyone. This is Eduardo. I would like to quickly introduce myself. My name is Eduardo Boronat. I am a security DevOps engineer at Kiuwan, and I also do customer success related tasks like contacting customers and trainings. Finally, as for my education, I studied computer science engineering, and I am passionate about cybersecurity. So I have been studying a master's degree in cybersecurity this year. Finally, the fun fact about me is that I am a fan of Real Madrid. Thank you, Sebas.
Great, thanks, Edu. Okay, thanks to you. We will do the webinar together. So what is the agenda of today? We will tell some words about what is Kiuwan, just a brief introduction. Then we will talk about the open source evolution. What is the current status of the open source? What we should consider when we are working with open source components. And finally, we will do a demo with my colleague Eduardo, where we will deep into the Kiuwan Insights. Okay, so what is Kiuwan? Or better, we can answer this question. Why do we need security analysis? As we can see in this graph, the number of vulnerabilities has increased a lot in the last years. This is a graph from the NIST, National Institute of Standard Technology. And we can see that the number of vulnerabilities last year, for example, it was 70,000. And many of them, as we can see here, around the 60% are critical or high. So it means that there are more vulnerabilities, and we need to check, we need to control the security of our software. What security analysis can you run? You can run different analyses. There are different techniques. And with Kiuwan, you can run static application security testing, more known as SAST. And you can run software composition analysis. That is the goal of today, because we will talk about how you can measure the security of your open source component. But in addition, you can govern all your application. You can have a full vision of all your application, the health of your application with the governance module. And you can analyze each delivery from your providers, from your development team with the lifecycle module. Both techniques, SAST and software composition analysis, are complementary, because the first one is looking for defects in our proprietary code, the code that our development team is programming every day. And with the software composition analysis technique, we are controlling the open source component, the libraries that we are including in our projects. If we talk about SAST, static application security testing, we need to say that Kiuwan is able to support the main security standards that are in the market, as OWASP, for example, or MISRA, or CWE, or PCI, or NIST. Kiuwan is able to analyze more than 30 languages, from all languages as COBOL, RPG, or SAP, since new languages as Golang, Python, Scala, Kotlin, and of course the most popular languages as Java, JavaScript, PHP, and .NET, and so on. Software composition analysis, we have said before that it's very important to control the open source component that we are using, and it is the goal of this webinar. We will see how we can reduce the risk using this open source component, these libraries, but not only checking the vulnerabilities that are in these libraries, but also analyzing the obsolescence of these components, because maybe we are using out-of-date components, and checking also the licensing, because we can use maybe not correct license for all the open source components that we are using. We will see some concepts as copyleft or copyright that are a type of license that we cannot use. Okay, so what is the open source nowadays? Maybe 20 years ago, at the beginning of the century, we were developing monolithic applications, and all the source code was in our proprietary. It means that we were developing our own source code. But during the next years, we started to use some open source components. For example, if I need to connect to a database with Java language, I can use the library JDBC. That is very useful for a developer because it saves a lot of time, because I don't need to develop the connection, I don't need to manage the pool with the database, I don't need to do the code of the queries, and so on. So it saves a lot of time. So it's very useful for a developer point of view to use this library. When we were in the 2010, just around the 30% of the components of the line of code in a project were open source. And now we are talking that around 60 or 70% of the line of code in a project, in a commercial application, are open source. So the question is, do I check the security and reliability of this open source component? Just to tell you some names, there are a lot of libraries just now, but some names: Spring, Struts, jQuery, Angular, Nodemine, Apache Tomcat, Bootstrap, JSON.NET, Composer, Symfony, for many, many languages. For Java, for JavaScript, for Ruby, for PHP, .NET, and so on. According to OWASP, Open Web Application Security Project, in the 9th position, we can find an important risk talking about security in our web application. The name of this risk is using components with known vulnerabilities. So here we will talk about the libraries, the open source component with well-known vulnerabilities that can affect, that can be attacked by a hacker or a bad user. There are many, many news that we know about different attacks due to open source components. 2 years ago, maybe you know, it is American company Equifax. They have suffered an attack because they were using Struts version 2, a specific version for Java, and they were receiving some attacks from different hackers in order to gather information, confidential information from their systems. After 2 months, the hackers had millions and millions of records. So vulnerabilities are discovered, are published every day. In fact, here, for example, there is a vulnerability discovered last week. So every day, the hackers know what are the last vulnerabilities that can affect our systems. Some metrics about open source components and the vulnerabilities that are in these libraries. More than the 80% of the commercial applications are using open source components, according to Gartner. 3 new vulnerabilities about open source component are appearing every day, according to the NIST. And there are now 20% more attacks to applications with open source component, according to the magazine CSO Online. So what are the goals, what are the objectives of the hackers? They know that open source is everywhere. So it allows to create only one single exploit, and it can be used all the times that they want. The use of these exploits are common find in commercial applications. It means that there are economical purposes behind an attack. Open source vulnerabilities are public, as we have seen before. We know that there are 3 vulnerabilities published every day. So the hacker can check this information and can prepare a specific attack for a specific vulnerability. They know that the companies usually don't update the open source component. They prefer remain in the version because the companies understand that it is a lot of work, a lot of impact to upgrade some libraries, so they prefer to remain in the specific version, but it is very, very risky. And the libraries are open source, so a hacker can have the source code, and can play and can prepare and can test specific exploit, specific payloads for some libraries. So what we need to take into account? First, we need to understand what are the full list of all the open source components that we are using. It's what we call the inventory. Of course, I need to check the security of these open source components. I need to control to see the obsolescence of these components in order to see if I am using the last version or the first beta version, maybe with many years ago. So it's important to be updated. And finally, I need to see the license behind these open source components, just to answer a question as, could I have legal problems? It is what we call 100 management of the open source components. If we talk about the inventory of the open source component, it's very important to understand what is the name of the component, what is exact the version, and very, very interesting to know the dependencies. Because when you add a library in your software, you need to include all the open source component that depends on this one. So you are including not only one, you are including a group of libraries. Talking about security, of course, and we need to put a focus on the most critical vulnerabilities that are in this open source component. Talking about obsolescence, maybe I am using a very old version of my library, so I need to be updated. I need to upgrade the libraries in order to be in the last version and to enjoy of the last features, to the correction of the bugs, the correction of the vulnerabilities, and so on. And finally, I need to check the licensing of my open source components, because it's very, very important to check if I am using an open source component with the right license. Imagine that it has a copyright, then I need to ask for permission to the author. Or if it has a copyleft license, it means that I need to do my application open source too, because it's a requirement for this type of license. So it's very important to check the license of my open source component. There are many types of license when we talk about the open source component, different agreements. We can see some names here, for example, GPL or License Eclipse, MIT, GNU, Mozilla, Creative Commons. And finally, what we need to know is if we can use or not. So if it has a public domain license, permissive license, or with copyleft or copyright. Okay, so now we can go to the demonstration in order to see how Kiuwan Insights can help us to reduce the risk when we are using open source component.
Thank you. Well, I'm going to, first of all, I'm going to share my screen. Great. So I think you can see it now. So now we are going to move to the practical part. We are going to see how an attacker could exploit a vulnerability coming from third-party components and how Kiuwan can help us to detect that vulnerabilities and to remediate them. So as you can see in my screen, I have here a Spring Boot application, which is the one that my colleague Sebastian has deployed in his machine. And as I am using Maven, you can see here the pom.xml file where you can add all the third-party components that your application will use. So as you can see here, I am using Spring Data REST because this application builds a REST web service where we can get resources from. So first of all, we are going to act as a developer would do. So let's analyze this application with Kiuwan to see if it detects any vulnerability coming from these third-party components. So for that, we will have to launch the Kiuwan local analyzer. And after selecting our application name and where is it located, we can continue with the process. We can also set here a label, like for example, version 1, and we continue. So now we will have to select which Kiuwan product we want to use. So as we are interested in detecting third-party components vulnerabilities, we will select Insights, which is our SDA product. So after analyzing, I have already done this analysis. We can go to our Kiuwan account and we will see the results. So Kiuwan is telling us that we are using 61 components and 8 of them have high severity. So we have to take care of this. So here you will see an overview of all your components, the number of vulnerabilities each component has, which version are we using, file name, and then we will see here some risks, obsolescence risk, license risk, and security risk, which we will see in more detail in each one of the following tabs. So today we are going to focus on one dependency, which is the one I was talking about before, which is this one, Spring Boot Starter Data REST. And I am using the version 1.5.6. As we can see in my project is this one, Spring Boot Starter Data REST 156. So Kiuwan is telling me that this component has one vulnerability, and this vulnerability is going to be exploited by me. So you will see how dangerous it is to have this kind of vulnerabilities. So now let's move to the obsolescence tab, where we will see information about the versions that we are using. So let's focus on the component we were talking about, which is this one, Spring Boot Starter Data REST. And we will see that we are using the version 1.5.6. And the last version released in the market is the 2.3.1. So Kiuwan is telling us that we are here and there are a lot of releases until the last version. So we should update our library. Here you will see that we are almost 3 years out of date. Then if we move to licenses, we will see that we have no problem with this application because we have known risk in the licenses our components are using. So, but we have to take care, because if you expand this license, for example, you will see that, well, we can do a commercial use of it, or we can distribute or modify that components, but we must take care, because there could be some limitations and under some conditions. And finally, we will have the security tab, where we will see all the CVEs of our components. So these ones that are very high are very dangerous. You should fix them. And if we look into the one that was detected in the Spring Data Rest library, which is this one, we will have here some description about the vulnerability. So it basically says that if you are using Spring Data Rest in versions prior to 1.5.9 in Spring Boot, that is our case because we are using 1.5.6, then an attacker could build a patch request and he would be able to run arbitrary Java code. So this is a remote code execution. An attacker could execute commands from his machine into the victim's machine. And that's what we are going to do today. So my colleague Sebastian has deployed this application in his machine, and I will attack him from home, so from my computer. Then you will see here some information about the system score. So in the version 2, it is scored with a 7.5, but in the version 3, it is a 9.8, which is, this vulnerability is critical, so it's very high. And if you click on the identifier of the CVE, you will be redirected to the NIST database, where you will find all the necessary information about how to fix this vulnerability. As you can see here, it is critical, 9.8. So now let's go to exploit this vulnerability. For that, an attacker could create a Java program like I did, which is this one, in which basically what he's going to do is to build a patch request and a payload. So he will execute this program against the machine, and he will be able to execute a code. So this vulnerability is called remote code execution. So for that, if I go here to run configurations, I can set the arguments. So this IP is where the web application is located, which is in Sebastian's computer. And then I will be able to set here a command. So what I'm going to try to do is to execute the calculator into Sebastian's computer. So please, Sebastian, can you share your screen? And after that, I will click on the run button, so you will see how the calculator is opened into Sebastian machine.
Sure. Let me share my screen. Okay, I think that now you can see my screen. Okay, this is the application that Eduardo has mentioned before. I have deployed in my computer. As you can see, there are some values. And what is most important is that I am using the Spring Library 1.5.6 version. So let me introduce some more values to my application. For example, I will introduce this value here in order to add more info. I have inserted the value Cristiano Ronaldo that I can check here that I have inserted Cristiano Rolando in this application. Okay, and Edu, if you are ready, you can attack my application. Let's see if it works.
Great. So now I'm going to run the Java program I mentioned before. So I will send a patch request to that application in Sebastian's computer, and you will see what happens. So I'm clicking into run now. It is sending the payload on, the calculator has opened. So an attacker could execute commands like, for example, open some programs, create some folders. Even he can create a folder, then collect all users' information, for example, office documents inside this folder, and then he could extract this folder using FTP, for example. So he will exfiltrate all the computer's important data. So this is a very important and dangerous vulnerability. And let me show you how you can fix this vulnerability with Kiuwan. All right, I'm going to share my screen again.
Okay, we can see your Eclipse now.
Great. So now if we go again to the application, which is the one that Sebas has deployed, and we go to our dependency file, then we could go to our dependency, which was Spring Boot starter data rest. That if you go to Kiuwan, you can see that this component was related to it. So what a developer could do is say, all right, Kiuwan is telling me that this vulnerability is affecting versions prior to 1.5.9 in Spring Boot. So I'm going to update that dependency. Instead of using 1.5.6, I will put 1.5.9. Even though there are newer versions, but well, with this version, we would fix this vulnerability in particular. So now the next step is to analyze again with Kiuwan. So we can go back, we select our application name, where is it located, and this is the version 2. We continue, and we select Insights as before. If we click on Analyze, well, the results will be uploaded to Kiuwan. I have already done this analysis, so we can go directly. So we go to our second analysis, which is this one, in which the CVE 2017-8046 was fixed. And as you can see now, instead of 8 components as before, now there are 7 components which have high severity. So it is true that we have fixed one vulnerability. And if you go here now, I think, well, I don't know where is it now, because now instead of having one vulnerability, it has 0. Let me look for it. Here we are. So now we can see that we are using version 1.5.9, and we don't have any vulnerability anymore. And if we go to the security, into the security tab, you will also see here that there is not the one related to the identifier related to that vulnerability. So thanks to Kiuwan, we were able to fix this critical problem. So an attacker cannot execute any code remotely anymore. So that concludes the practical part.
Just to say thank you to everybody. Thanks for your time, for your attention. It has been a pleasure to be with you today. and see you in the next webinar. Thanks.
Thank you very much.